the the impact of the environment in pediatric health. And so how it'll work is Dr. Zachariah will present, and then we'll have time at the end for Q&A. So if you have any questions, feel free to put those in the chat or reserve those at the end. But without further ado, I'll go ahead and pass it over to you, Dr. Zachariah.
Thank you, Wes, and thank you all for your attention today and for the invitation. I'm really excited about this opportunity to talk to you all a little bit about environmental health exposures and pediatric cardiology per se, as an aspect of pediatric medicine, because it's something that's just starting to emerge, but is emerging in a big way. And so I thought that this group would be very interested in some of the findings that have been emerging in this space. There's probably about a half an hour to 45 minutes worth of slides, but I think it could spark a nice discussion among the group about interest and so forth. So again, I appreciate the opportunity. So I'm going to try to share my screen here. And again, as you all know, once I start sharing my slides, I won't be able to see questions in the chat and that sort of stuff. So I don't mind being interrupted, but if you want to save your questions till the end or interrupt in the middle, I don't mind either way. Right. I'm hoping that you all can see my slides. So environmental exposures in pediatric cardiology. I do have disclosures. I am supported as an independent investigator by the NHLBI, NIH, but otherwise I don't have any other financial conflicts of interest, and no unapproved medicines or devices will be discussed during the talk. So roadmap. I'm going to start off by giving you some definitions because not all of you are knee-deep in pediatric cardiology the way that I am. And then we'll launch into talking about 4 different aspects that I think are emerging in this space as sort of archetypal examples of how we can start to think about this. One is associations between climate change and congenital heart defects. Another is airborne particulate matter and its association with Kawasaki disease. Another is lead exposure, or that is blood lead and its associations with blood pressure. And then finally, plasticizers and endocrine disruptors and their association with cardiometabolic risk factors. And again, all of these related to children and adolescents. Okay, so some definitions. What do I mean by pediatric cardiology? Pediatric cardiology, generally speaking, as it's understood around the world, has at least 3 different facets. The first is, and the bulk of which is congenital malformations of the heart. In other words, birth defects that affect the patterning, structure, and/or function of the heart. Now, these things that you're born with can be structural right from the beginning, or can be sort of latent in your muscles that then develop as you develop, either due to changes in your diet or changes in your genetic expression or epigenetics and so on and so forth, such that they can develop at a later time, but you have the genetics for that from the beginning, or some other non-voluntary issue from the beginning. A second is acquired heart diseases during childhood. So children can acquire different types of heart diseases, often inflammatory heart diseases, throughout the life course due to mechanisms that are not completely understood. And finally, children can start to develop risk factors for heart diseases that generally affect adults, like heart attack, stroke, heart failure, those sorts of things. The seeds of those problems are planted during childhood. And so that's the third aspect of pediatric cardiology that we can sort of understand writ large. If we then move over to causes for these various facets, generally speaking, causes for these various aspects of pediatric cardiology are outside of the child's control. They can be genetic, they can be epigenetic, or changes in how the genes themselves are expressed. It can be due to other parts of developmental biology. It can be due to sociodemographic factors, food and activity, and what's now emerging, could it also include environment? But the common theme around all these things, and sort of a crystallizing aspect of this, is that the volition of the child or the choices of the child are generally not felt to be determinative, right? We don't ascribe a level of responsibility to a newborn that we do to a grown-up like me, right? Whatever's affecting that newborn generally is not something that they've done for themselves. And so it behooves others around them that care for that child to sort of step up to the plate and protect that child's health. And so exploring these aspects in pediatrics also has a different, both moral element, but also political and other policy element to it. Okay, so what do I mean by congenital heart defects? Well, congenital heart defects, it turns out, are the most common birth defect in humans. The classically quoted number is about 0.8% of all live births. That number has been altered over years to being closer to 1% or what have you. But basically, what we're talking about is diseases that are there from birth and affect the child during childhood. Now, there are some other malformations of the heart that generally don't affect the child. They only show up when you're an adult or even an elderly person. That's not what we're talking about today. Now, if we say that 8 of every 1,000 live births have any kind of congenital heart disease, well, that's not what gets us excited here at Texas Children's Hospital, because most of those will sort of resolve themselves. What we care about are ones that need some kind of intervention. And that's about half of that group, so about 0.4% of the population. But what gets us really interested are those that require some type of intervention during the neonatal period, in the first month of life, what we call critical congenital heart defects. And that's about half of that group, so about 0.2% of the population, or 2 in every 1,000 live births, have a heart defect that requires intervention within the first month of life, or else morbidity or mortality may occur. And some examples of those are given here, including a severe narrowing of the big blood vessel that comes out of the heart and feeds the body, called the aorta. When that's very narrowed down to a pinch point, we call that coarctation of the aorta. Or if severe enough and it's completely cut off, we call it interruption of the aortic arch. You can have holes in the walls between the left side and right side of the heart, especially along the bottom pumping chambers, that we call a defect in the ventricular septum or wall, or a ventricular septal defect. Similarly, we can have holes in the top chambers of the heart, an atrial septal defect, as the top chambers of the heart are called the atria. We can have a disease called tetralogy of Fallot, wherein the big blood vessel that takes blood to the lungs, which is called the pulmonary artery, can be quite narrow, and that extra space is given over to the aorta, which cheats across the ventricular septum and kind of overrides the entire middle of the heart. And in this situation, there isn't enough blood flow to the lungs and returning back from the lungs, and therefore the child will have excessive blue blood or deoxygenated blood going to the body, leaving them blue in their mouth and in their bloodstream, for that matter. And that's kind of a classic lesion as well. And then other types of lesions, maybe even more severe, wherein it doesn't allow blood flow through an entire side of the heart, and therefore that side of the heart doesn't develop, so-called hypoplastic left heart syndrome, or a similar phenomenon on the right. And so what I'm trying to get at is here, I can't go through every particular kind of congenital heart defect, because every structure that you see in this middle picture can be malformed in some way and thereby cause moderate to severe dysfunction in that child's life. And so you may imagine that with this many ways things could go wrong. First of all, it's kind of a miracle that it ever goes right. But putting that aside, as many problems as you could have are causes that might be present. And indeed, the vast majority of cases of congenital heart defects, we do not have causes for. We think genetics are probably involved, developmental biology is probably involved, because the heart is structurally patterned within the first 2 months of gestation. So by 8 weeks of pregnancy, the heart is pretty much formed what it's going to form. And then it just grows in size as the baby grows in size. So these are all very early influences in most cases. So this is an appropriate slide for the next part of this. It literally found this morning, commenting on climate change and whether unborn persons should be given a voice in policymaking. So I thought that this was just serendipitous this morning, so I thought I should share. In any case, several studies have now been published looking at climate change and specifically global warming with respect to its epidemiological association with congenital heart disease. As I just told you, we don't know what all the causes are. So some clever people started to ask the question, well, could it be related to temperature? And the reason they came across this idea is because it is well known that maternal hyperthermia is a teratogen. That is to say, mothers who have fever during their pregnancy are at higher risk of various types of birth defects. That's been well documented and demonstrated in epidemiological studies of humans and also animal studies, wherein when the mother was overheated by various mechanisms, there were characteristic birth defects noted. Top amongst those is neurodevelopment. There are neurodevelopmental problems that can occur from that, but heart defects are also found. And so that's where this idea came that, well, could external temperature be enough to raise mother's temperature enough to affect the fetus? Now, these would most likely be very subtle effects because, of course, humans are not poikilotherms. We're not cold-blooded animals. We kind of regulate our own temperature, makes us what we are. But if it's bad enough outside, and those of you who have actually been pregnant in the past will know, your body runs hot after a little while. And Houston summers can be pretty tough when you're pregnant. And so that's an indicator that our normal homeostatic mechanisms are not perfectly functional during the pregnancy. And so that's where this sort of idea came from. It wasn't just sort of a, let's see if the spaghetti sticks to the wall kind of an idea. There is some conceptual basis behind this. And what you can see here are graphs that they presented about the number of days with temperatures that are elevated in a month and the odds ratios of having a ventricular septal defect. And what you'll notice is with many days in the summertime of having very hot days, the likelihood of having one of these congenital heart defects rose greatly. But what was interesting was the presence of such days during springtime seemed to increase your risk even more. And the concept here is that the body's homeostatic mechanisms progress during the course of the year. So in other words, as it starts to heat up gradually, your body starts to build up its mechanisms to deal and cope with that heat. But when the heat happens at times before your coping mechanisms have sort of fully established themselves in what are called shoulder seasons, like early spring or late fall, when you have these out of step, unusual heat spells where your body's just not ready for that. And so that shock might be more deleterious and detrimental than sort of your usual Houston August, or at least that's what these slides are trying to tell us. Authors then tried to look at various specific forms of septal defects and found that perhaps atrial septal defects are more prone or associated with extreme heat events than are ventricular septal defects. And then other studies have looked at it in terms of other severe heart diseases, including the severe ones that we noted earlier. And what we'd like to just take away from this is many of these disorders that are earlier in the life course appear to be less affected than those with later occurrence. That is to say, during the gestation, there are some structures that are patterned very early on, and there are others that kind of form and close themselves out during the growth process. And it seems that those later processes are more prone than are the earlier processes to being associated with global warming and health change. And that's also being demonstrated here in terms of the maximum temperature achieved and its associations at various points in the life course, appearing that later in the life course appears to be worse. Later in the gestational course, I should say. So based upon this, if we start looking at projections based upon current climate models, projected increases in congenital heart defect cases are not trivial. And what you'll notice again is that concept of being out of step. So the South, where we're kind of used to being hot and humid, there seems to be less projected increase in congenital heart disease versus, let's say, the Midwest. As the Midwest gets uncharacteristically hotter, it appears to have a worse projection, indicating less accustomization or acclimatization to warmer temperatures. And so that's the way to sort of parse this graph. And these are just numerical instances of exactly that concept. So what are some possible mechanisms for this? Well, direct heat can cause fetal cell death and placental insufficiency. There's strong evidence that there are some proteins around the body called heat shock response proteins that are ubiquitously used by the body in response to a variety of different stresses. But these may alter transcription and translation of normal proteins during the formation of organs. Temperature may also directly activate or alter ion channels in the body, such as these TRPV1 and TRPV4, which are present in neural crest cells during the critical windows. Neural crest cells are essentially found in the early part of the embryo that drives the formation of brain and spinal cord, but those same cells do migrate to other parts of the body, including the heart, the aorta, the pulmonary artery, guts, and various other places. So these neural crest cells are like homing beacons to find their other eventual use places, and alterations there in neural crest cells can therefore have wide-ranging effects in various other organs that are not strictly neural. And we talked earlier about having high temperature in summer when you're acclimated may be different than transitional seasons when you're not acclimated. And there appear to be interactions between these climate change models and climate heating and maternal medication use, chronic diseases, alcohol drinking, smoking, caffeine consumption, or maternal occupation. So one can imagine that epidemiological analyses of these, trying to figure out how to tease these apart, can be very, very complicated and is going to need smart people like yourselves to help us sort that out. Okay, so let's turn then to our next disorder, Kawasaki disease. Kawasaki disease is one of those acquired heart diseases that kids can get at some point in their childhood. And it's a very serious condition that can be defined as having fever for more than 5 days and having lymph nodes that are large, characteristic rash, characteristic swelling of the hands and feet, red, or what we call strawberry tongue, indicating inflammation of the mucosal areas, and then injection around the eyes. That is, the eyes turn kind of bright red. And the other thing that's on there that's not listed is the kids are very irritable, probably indicating that they've got a bad headache, especially the young ones that can't tell us so. They're very irritable, more so than their normal personalities, probably indicating inflammation in their brains as well. And for the heart part of this, what happens is a very, very unusual inflammation in the blood vessels that feed the heart, called the coronary arteries, such that these coronary arteries start to get large, very large, or even what we call giant aneurysms. And when those aneurysms dilate, when those blood vessels, rather than being svelte and narrow the way that they're supposed to be, start to get big and boggy, Well, that's bad for blood flow. You don't want to have eddy pools and tide pools in your blood vessels, because then blood starts to stagnate in those areas and can clot off. And when coronary arteries clot off, we call that a heart attack. And so these little kiddos, all the way down to infancy, can be subject to having the equivalent of an adult heart attack. And so this is obviously a very dangerous disease, which we fortunately do have some treatments for, but it's still a tough problem. And quite frankly, is quite a mystery as to what its causes are. There clearly are some race, ethnicity related associations, and there appear to be seasonality to these, such that when there seems to be a season to Kawasaki where we start to see crops of this disease and then periods of the year where there's a lull. And so that had previously been attributed to seasonality per se, that, you know, spring was the right time or the wrong time, or that there might be something, seasonal allergies or allergens might be at work. But then again, people started to ask the question, hey, listen, could this be related to some type of toxic environmental exposure? And one of the exposures that was explored was airborne particulate matter, because I'm sure, as you all know, airborne particulate matter has been associated with inflammatory respiratory conditions like triggering asthma and so forth. And so some clever people asked the question, well, could it also be triggering off this somewhat mysterious and thankfully rare illness called Kawasaki disease? And so they started to look at it. And I think this one study, and there have been a handful of studies in this space, but in this study from Japan, looked at suspended particulate matter exposure and Kawasaki disease hospital admission. And in fact, they did find that there was an association, but that association mattered as to whether the association was prenatal or postnatal. And what they found was prenatal exposure to suspended particulate matter was associated postnatally with incidence of Kawasaki disease. So somehow the exposure during in utero life predisposed the child to have an inflammatory predilection or predisposition, such that later on, after they were born, months or even years after they were born, they went on to have Kawasaki disease. That association was not as strongly developed when exposure occurred postnatally, suggesting perhaps that there is a critical window during which this may be at work. And it appeared that this there was an interaction by season, that when it happened during cold weather season, it was more predictive. The particulate matter was more predictive, and separated by age as well. So again, the basic concept here is that it's a quite complicated association with a lot of interactions that have to be teased apart. Now, one of the things that was okay, and so sorry, here's one of the things that make this very epidemiological association more plausible is in this same study, they were able to show the expected association between particulate matter and asthma. In other words, they used their metrics or their indices of particulate matter exposure and its association with asthma as a positive control on an epidemiological basis. The argument being, well, if you believe particulate matter is associated with asthma, that same particulate matter was associated with Kawasaki disease. And that's very important for skeptical cardiologists such as myself, who have never been trained in this space. Now, to be clear, there are contrary data. And this is postnatal data showing no apparent association between particulate matter and Kawasaki disease. And again, this data comes from the US, whereas the previous positive data that I showed you came from East Asia, specifically particulate matter exposure in Japan on the basis of particulate matter that was being blown in from China. So there was also a geopolitical element to it, as well as tropospheric, atmospheric wind patterns, and so forth. So it's quite complicated as to how to even model all this sort of stuff. And there is controversy in this area. So I just wanted to be upfront and forthright about that. What are the possible mechanisms? Well, triggering maternal systemic inflammation can then lead to inflammation in the cord blood and then altered postnatal immune responses by virtue of which cytokines are already upregulated in the baby. Likewise, oxidative stress is known to alter fetal lung development and therefore postnatal susceptibility to environmental agents. For example, particulate matter exposure in utero can make you more prone to asthma triggers later on in your life. Could a similar process be happening with respect to Kawasaki disease? And finally, prenatal exposure is often believed to affect development and later life, and even multi-generationally, by epigenetic changes. That is, environmental exposures alter the structure of how your genes are coiled or eventually transcribed, and that can then alter your immune programming. So there are a lot of purported mechanisms for how this could be happening, but the epidemiological associations are very suggestive. Okay, so let's turn to our third topic. As I'm sure you all know, pediatric obesity in the US and in fact around the world has tripled and more. And so as you all are also aware, blood pressure is associated with obesity. Therefore, I would assume that you would agree with me that if obesity in children has tripled, blood pressure in children must have also gone up. Well, here's what the actual numbers look like. From 1970 to about 2010, the proportion of children in the nationally representative NHANES study, the proportion of children with obesity has climbed from roughly 5% to more than 20%, and that number continues to go up. But systolic blood pressure in boys and girls is given in the boxes and the triangles, and you'll notice that it's not going up. If anything, it appears to be flat, if not decreasing. And this is the population average systolic blood pressure. If we turn to diastolic blood pressure, the bottom number on your blood pressure number, again, obesity in the open circles going up, you can see an even more dramatic downward trend. If you're like me, I found this very confusing. I was pretty sure blood pressure should be going up, and in fact, it was not. When you look through, there's actually a sneaky little secret that's going on. This same trend is true in adults. Now, the adults, when you ask, and this is from the Global Burden of Disease study run out of University of Washington and the WHO. And when you ask the folks who are running the Global Disease Burden study why they think it's going down in adults over 40 years, all over the globe, they'll notice, they'll argue, well, that's because we're doing such a better job of treating high blood pressure adults to bring their blood pressures down. And then I'll retort back, well, it's happening in kids and we don't treat kids with high blood pressure. And you can hear crickets start to chirp. It turns out another sneaky little secret is this trend is not just present in the US. It's been present in Northern Ireland, South Korea, the Seychelles, various different countries around the world of various different per capita income have found this same trend, especially early in those years from 1970 to 1990. And so we were a bit confused about this. How can this be happening? So then we tried to decompose blood pressure into its component parts. And its component parts are what's happening in the large blood vessels that just take the blood from point A to point B versus what's happening at the small blood vessels that are actually delivering the blood to the places that need to extract the blood. Large blood vessels are measured as pulse pressure, or the difference between systolic and diastolic blood pressure, whereas mean arterial pressure is calculated in a different way, and it reflects small arteries. And what you can see here is white circles being the obesity, pulse pressure did seem to be going up in parallel with obesity. So that makes sense. But mean arterial pressure, that is the small regulator, small flow blood vessels, are dropping like a stone. Now, this has to be happening in the absence of healthcare, because the vast majority of kids in America are not on medicine. They're generally healthy and well. And it can't be due to the obesity, because the obesity is going in the other direction. So the other thing that we looked at was smoking. Cigarette smoking, thankfully, has gone down over this period substantially, but measured nicotine levels in the blood, or cotinine levels as the index is called, nor survey-derived smoking was associated with this trend either. So we said, what other population level trend has happened over this period? And it occurred to us that environmental measures, and specifically blood lead, might be a player. And here's what we found. The white circles is that same trend in mean arterial pressure, and the black boxes are blood lead level averages in that same population. And what you can see is a very parallel increase. We then did the multivariable association on a participant by participant basis. And when you accounted for the blood lead level in the child's bloodstream in relation to their blood pressure, lead level accounted for nearly 70% of this downward trend, leading strong suspicion that perhaps the improvement in lead level is leading to this stabilization in blood pressure. And in fact, if that were true, we should start to see an uptick in blood pressures now that lead levels have been at a baseline for a long time. And in fact, that is what we're seeing. The more modern trends in blood pressure appear to seem that it's ticking up. So to be clear, it is the case that obesity has increased. It is the case that blood pressure is associated with obesity. It is the case that those obese kids do have higher blood pressure. But what we're saying is there's a countervailing trend, especially in normal weight kids and in the obese kids, but especially the normal weight kids, such that as we've been able to bring down their lead level, their blood pressure has come down also. But as I don't need to tell you, there is some inequity into that lead decrease, both on a global scale, but also on a domestic scale, as you know about the slow rolling disaster that's happening in Flint, Michigan. What are some possible mechanisms for this? Direct smooth muscle effects by cation substitution. In other words, calcium is a ubiquitously used ion in a lot of different body organ systems. Lead can sort of try to take its place, but doesn't do a good job and ends up being toxic. Next, lead can be a cause of direct blood vessel fibrosis. And if your soft and supple blood vessels become as hard as lead pipes, your pressure goes up in those pipes. Also, we cannot exclude that there may be some other confounding exposures that may be responsible for the lead. This is not a direct causal linkage. But there are studies in adults, especially adults who work with lead quite frequently, that seem to suggest that this may be a real phenomenon. And similar associations have sometimes been found in adults and sometimes not. So there is some controversy in the area. Okay, we'll turn on to our next topic. This is a picture, obviously, of the World Trade Center in New York City. New York City doesn't look like this anymore due to the terrorist events and terrorist tragedy of September 11, the World Trade Center. The World Trade Center was a disaster on September 11, 2001, and that disaster has not ceased. Beyond the geopolitical ramifications of what happened on that day, besides the tragic loss of life on that day, people are still being affected by the after effects of that disaster. That disaster, we're increasingly coming to understand, had a multiplicity of effects from the demolition, the sudden demolition, uncontrolled demolition of these buildings built in the 1970s, which contained a variety of environmental toxicants, including asbestos, plastics, jet fuel, metals, dust, metal, and a variety of other factors. And so investigators under a federal grant that's been funded for 99 years to help with deal with health effects of the disaster for the foreseeable future have been trying to study the effects. And one of the hypotheses were that the rapid incineration and deposition of ubiquitous molecules associated with the plastics in those areas could be disruptors of the endocrine system and therefore lead to alterations in cardiometabolic risk factors in youth. That is to say, endocrine system is involved in blood glucose regulation and other hormones. Those blood glucose, insulin, and sex-related hormones have important effects on diabetes risk, cholesterols, blood pressures, and downstream effects of those things on blood vessels, hearts, et cetera, and heart disease risk. In adults, the World Trade Center has been significantly associated with aerodigestive disorders, such as gastroesophageal reflux, obstructive sleep apnea, a weird form of asthma that doesn't respond to normal therapies in both survivors and first responders. Obviously, PTSD and other neurocognitive disorders. Cancer has been noted to be increased in this population, including prostate and other cancers, but also cardiovascular disease. Cardiovascular disease has also noted to be higher in both survivors and first responders to the World Trade Center than would otherwise be expected in adults. Well, one of the investigative groups started to look at adolescents who were exposed. And again, the timing here gets a little bit tricky, and the exposure needs to be a little bit tricky because they shouldn't have been working there, nor should they be first responders. But there are residential neighborhoods just around this area. And what they found was, number one, what was the association between various types of exposure to the World Trade Health Center and the blood levels of various kinds of plasticizers or endocrine disruptors, the acronyms of which are given here on the left column and the full forms of which are given down in the legend down here. Various different kinds of plastics associated chemicals and their blood level being associated with different types of exposure, either directly to the dust cloud on September 11th, home dust being deposited in your home as being measured by the health program, exposure to the trauma itself directly, or being in the household of a first responder. And you can see how these different levels were associated with different levels of exposure. They then looked at the relationship between exposure to those various chemicals and things like obesity, triglycerides, insulin resistance, cholesterols, blood vessel function. And you can see key association between several of these kinds of plasticizer endocrine disruptors and various types of cholesterol, including triglycerides, LDL, HDL, and so forth. Less so for vascular function, less so for obesity as a consistent finding, but for the cholesterols, definitely. And these cholesterols are the ones that eventually go on to lead to blood vessel changes, heart attack, stroke, heart failure, and the like. Possible mechanisms: these plasticizer endocrine disruptors have an affinity for certain molecules called PPAR alpha and PPAR gamma that alter sensitivity to insulin, diabetes, and so forth. And these same kinds of molecules also increase estrogens and decrease testosterone, which can have differential effects depending on what type of body you have, a male body or a female body, about which of these is supposed to be stronger or weaker in your body. And what we find is just a general rule: when your biological sex is being disrupted, that's when your body systems start to have the most stress put on them. So overall, in summary, climate change may be affecting the incidence of congenital heart disease. Airborne pollution may be associated with the incidence of Kawasaki disease. Blood lead levels may be responsible for historical trends in pediatric blood pressure, and perhaps even in modern trends. And plastics-associated chemicals may be endocrine disruptors associated with cholesterol problems and insulin resistance. These exposure effects may vary by the developmental stage of the child. And finally, children need champions to do what they cannot, protect their health. With that, I thank you for your attention, and I'm happy to take questions if I can figure out how to stop sharing. Stop sharing, yes. So I'm happy to take questions.
Great. I saw Ahmad, you raised your hand, so feel free to go ahead.
Sure. Hi, Amr Hashmi. I'm from the School of Public Health at UT Health. And I really grateful for this wonderful talk, really good talk. I was applauding. So, but I actually did have a question. So if I can, I haven't been engaging with this group as much, but thank you all for putting this on and having such a wonderful set of speakers. I always get bummed out when I can't make it. One of the questions I had was, we talked a little bit about the burden of congenital heart defects. We didn't spend a lot of time on Kawasaki disease, but we can assume that its burden is also a little bit lower than perhaps other problems. But I liked how it was connected to exposures, especially with Kawasaki disease, with its relationship with other reactive airway diseases. So I think what I would hope maybe some others of us are also thinking about is how to take what we understand from things like Kawasaki disease, where you connected the level of exposure to particulate matter that's also related to things like asthma, which we as a community see way more often, and how to take interventions that might help the least of us, maybe someone suffering from Kawasaki disease, and what would that look like, or how would that translate to maybe bigger questions that our communities might have around lots of other children who might suffer from asthma. So sorry if that's a really long preamble, but
No,
how do we take, yeah.
I appreciate your comment and the thought behind it. And so I think that you really hit the nail on the head as far as one of the great challenges for us. We in pediatric cardiology are generally plumbers and electricians. So we're very sort of focused on sort of the mechanics in front of us and fixing the problem that we are sort of dealing with. And so it's trying to get our heads around very low level causal agents is very hard for us, right? And you all deal with this, especially in the asthma space, but because there's a bit of immediacy to it and a bit of prevalence to it that allow you to make those associations. The types of associations that we're talking about here are on the order of like a 10% increased risk, 12% increased risk, which in the grand scheme of numbers is very hard for us to get our heads around as clinicians or even consumers. And so I might suggest that number one, in order to establish these associations, you need very large numbers. So any one neighborhood or any one city even may not be large enough to see these. You're gonna have to look at this on a regional basis or on a national basis and so forth, because you're just not gonna see the numbers and you're not gonna be able to catalyze that. Next is the other way to do this is to also treat these conditions as an add-on. All of us, myself most of all, very focused, very blinders on to my space. Cardiology, cardiology, cardiology. If I open up a little bit more and I say, wait a second, asthma too, diabetes too, rheumatic rheumatoid arthritis also. If we start looking at it more holistically and we start looking at, okay, exposure to not just this narrow thing, but exposure to this broader thing, now when you're doing your analysis for asthma, maybe pull in the ICD-10 code for Kawasaki also, right? And so you start to build that as, so rather than allowing the organ system or the medical specialty to define how your associations are going to work, maybe you look at it as, okay, I'm going to make this intervention on the particulate matter. Let me see all the diseases that it's helping. And let's build those numbers out and treat them as a group. That changes the frame of your effectiveness. I don't know if that makes sense, but I think that's how I would sort of attack the question.
That's really great. That's very helpful, I think. Thinking about what can we do at policy levels, or what can we do in our communities, and how can we show the benefit and the impact of what those things that we are doing. So if we're trying to reduce the risk of exposure to lead, or which has many varied benefits across diseases, not just for the blood pressure question that you rose, but and also for the reactive airway diseases, which have a lot in common too. So thank you. That's a great answer. Thank you.
Happy to.
Rosalia, did you have a question as well? I saw your hand was raised earlier.
Oh, I was also applauding. That wasn't applauding. Thank you so much. That was great.
Real quick, Katie Butterwick, you posted 2 articles for those who might not see in the chat. Do you want to explain them?
Yeah, absolutely. So Dr. Zachariah, thank you so much. I think we had a chance to meet some years ago when I was at the Episcopal Health Foundation. My colleague Anna Steiner and I spent some great time with you in your office there. So thank you so much. I wanted to just share, I keep tabs on a lot of early childhood movement and information, and this call for climate crisis movements and early childhood development movements to unite is coming up more and more, right? We saw a lot of emphasis at the COP26 climate, there's just, it's coming. And so I feel like this is an amazing primer and introduction to the fundamental science that underlies why this is so critically important. And it's an invitation for all of us to lean in around this concept in different ways, right? So thank you. Thank you so much for being a voice for this. And I'm excited to share these resources and others. So appreciate everyone on the call. Thanks for making this space.
Thank you for your comment. And I think I think it kind of dovetails with what I'm talking about is if we frame it from the cardiology piece, it's going to be hard for us to make the case. I'm in the process of trying to make the case in various areas. But if we come at it from the other direction of, we know that this particular environmental exposure is bad and its mechanism is the following, what are all the different health effects of that mechanism from that exposure? And then you start to look at it in a more holistic way, and you can start to build the case a little bit better. The pushback you get back are from skeptical people like my colleagues, who sort of are very sort of narrowly focused. And I think a very strong argument is, take your blinders off. The fact that it's not as appropriate to your particular niche or your space, that's a you problem. That's not a exposure problem.
And I'm sorry if I'm saying your name wrong, but Simbo Chiarika had said, great talk, was not aware of the connection between lead exposure and increase in mean arterial blood pressure. How well disseminated is this information?
Thank you for that question. It's published. As far as dissemination is concerned, it's hard. There are lots of things that are published that aren't getting out there. We're doing our best to sort of highlight this space. And again, it's a single study about a historical phenomenon. But I think the phenomenon itself has legs, as I said, with respect to what's going on in various underserved populations around this country and in countries around the world that don't have the strong ministries of environment to enforce lead laws and other lead exposure issues, and also places that take our effluent in terms of lead containing compounds and use that as salvage materials, and the exposure of those often underclass communities and so forth, underserved communities So I think it's still a relevant issue, but yeah, I think it is something that needs to be highlighted a little bit more, but it's hard to get traction because we all think the problem is solved, right? My house doesn't have lead, so what does it matter? And sort of getting it reframed into something that gets more relevance is something that the paper doesn't actually do. Paper just reports the facts, not the sizzle, as it were. Thank you for that comment.
So Dr. Zachariah, you mentioned that, in your field, there can be, I don't know if this is the right summary, but maybe isolation with different specialties in the focus. How do you think there can be a change where, people who, other specialists can see information outside of their field as relevant to their work?
Yeah, that's pretty hard. We're all very insular, and in places like Texas Children's is a huge institution, we get more insular within our insularity. So you're not just a pediatric cardiologist, you're a tetralogy of Fallot expert, or you're a Wolff Parkinson White expert. And so you really sort of drill down because there's enough for a person to fill their career just in that space. I think engagement through activities like this is helpful. Conferences and meet and greets to sort of get people talking to each other who are in this space, I think is useful. And some of us in leadership roles that we have in various professional organizations are trying to raise the profile of this issue such that it gets on the agenda of discussion and gets highlighted in those areas. So, we're trying to fight the good fight, but I don't have great solutions for this. And I'm really happy to take your thoughts on how to make this happen. Especially in the post-COVID era, how people interact with each other in the medical community has really made a substantial change. There's a qualitative difference in how interested people are at taking their leisure time and going to a conference or participating in various other academic non-remunerative activities. The review of medical manuscripts, serving on various committees, going to conferences, all of these things have had a qualitative shift after COVID. And so I don't know what the right way is to get people engaged. Maybe it's Twitter or Instagram or something. I don't know. I don't know what the new water cooler is.
Well, thank you so much, Dr. Zachariah, for this information. This has been a really great talk. I'm also with the School of Public Health, and I work with a lot of students, and we're trying to, build more connections within the different arms of the university, right? Trying to talk more to the medical schools and, to the nursing school, the dental school, et cetera. So I'm wondering if there's a way we can kind of motivate students to start building these connections early on in their careers. And, I don't know if there's a way to motivate them to, just to, I don't know, maybe hold on to these connections as they're meeting people from different specialties, or as people start to develop their specialties. A lot of times students are just motivated by grades. Mm-hmm. So I don't know if we need to encourage them that way, but I'm just wondering if there are some kind of pathways or mentorships that we can kind of start building so that this is ingrained in people kind of early on in their training, and maybe, they can kind of develop a good habit.
I thank you for that comment. I think it's very on point. I might suggest that reaching out to young people is absolutely critical to this, because they're the people who are going to start to change this tide. It's not going to be people my age and older. It's not happening. It's going to have to be the young people who push this agenda. And I might argue that once they've gotten into the trade school aspect of their career, that's going to be too late. They're going to be so focused on what they're doing. Adding yet another thing onto that is just that they don't see a payoff for is going to be problematic in terms of getting that off the ground. And so I might suggest along that line, one step earlier, college clubs, and really fomenting it at that level, because commitments, what's going to happen is some people are going to be, you're going to get a lot of people who are marginally committed in college, and a few people who are very committed. And those very committed people will continue that commitment in through the trade school period, just in terms of how the life course of your career works. And so getting them earlier and then supporting them once they get to the trade school, I think is going to be more fruitful than trying to get them on board when they haven't been up until that point, because they've been so focused on getting into school. They're just, that's their major focus. So trying to get them earlier in the process might be the way to go. And at a selection criteria basis, getting the selectors, meaning admissions committees and stuff like that, to start looking at this as one of their criteria for community service and really valuing that piece, because that sort of information does get out. And then people start to say, hey, listen, this school really appreciated the fact that I was in this environmental space and was sort of talking about that. And obviously, when they have something else for them to plug into on the other end, they've got a really great department or program that's looking at environmental health. And so this becomes a natural fit for me. Then the school's interest in it becomes an asset for young people that are interested in it. And then you sort of bridge both ends of the connection. But trying to get them when they're in school and get them interested at that point, they're at a stage in their lives where the horses are already out of the barn at that point, I think, in terms of.
I know that was great. Thank you so much for that.
You bet.
Well, it's 9:30, so want to be respectful of everyone's time. Dr. Zachariah, thank you so much for taking the time to present and enlighten us with this information.
Thank you.
Yes, no, seriously, thank you. It's great to have physicians with, brilliant minds that you all have, and also have this aspect to look at things beyond just the studies and the insular perspective. So thank you. Again, everyone will post this on Mighty Networks. For those of you who might not have it, I put the QR code up there. If you're not a member of that, all you have to do is scan the QR code to join it. But thank you all again, and we'll be sure to post these resources and stay tuned for other events coming up. Thank you.
Thank you.